Have you ever started a small Rust project that, well, suddenly wasn't so small anymore? We've all been there. Today, we're going to tackle that exact problem by unlocking a feature that is absolutely essential for any serious Rust developer: Cargo Workspaces. This is the tool that keeps your project sane, scalable, and, yeah, even fast. Let's dive in. So, let's start with a story that's probably really familiar to any developer out there, no matter what language you use. It's that moment when your beautiful, simple project starts to, well, get a little messy.
I mean, really think about it. That side project or that new app at work, it started out so clean. But now it's got off, and a database layer, and maybe some background jobs. Is your code structure actually keeping up with its complexity? Or does it feel like you're starting to fight it every day?
And this right here, this is the classic list of symptoms. The code base becomes this giant tangled ball of yarn. Your compile times start dragging on forever because one tiny change forces a recompile of the whole thing. And trying to test just one piece of logic in isolation, oh man, forget about it. It's a super common pain point. But thankfully, Rust has this really elegant built-in solution.
And that brings us right to the hero of our story today. We've seen the problem, so now let's talk about the solution. So what is a cargo workspace anyway?
Well, the definition is actually beautifully simple. It's just a way to take a bunch of separate but related projects, or crates in Rust speak, and manage them all together as one big unified thing. Think of it like one big project that's made up of smaller, independent parts that all work together seamlessly.
So this is what that basic structure looks like in practice. You've got your main folder, My Workspace, and inside, one super important file, that cargo.toml at the very top. That one file is the boss. It tells Cargo, hey, everything in here, all these crates, we're a team. Then you've got your individual crates, like crate A and crate B, and they each get their own cargo.toml. It's just so organized, clean, and really, really powerful. So what do you actually get from doing this? First, you get one master cargo.log file for everything. This is huge. It means every single crate is using the exact same version of every dependency, no more version conflicts. Second, you get one single target directory. This means shared dependencies only get compiled once, which can make your build way faster. Plus, you can share settings and run commands across the whole project at once. It's really the best of both worlds. You get modular code with totally centralized management.
Okay, theory's great. But what does this actually look like when you're building something real, something complex? Let's break down the anatomy of a modern web backend built with Rust. Let's put on our architect hats for a second. Imagine we're building the next big thing, the backend for a social media app or a massive e-commerce site. We're going to use Axiom, which is a really popular web framework. Now, a project like this is going to get big fast. It has a lot of different jobs to do, and they all need to be managed properly. Now this is what a real production-grade workspace looks like. You see that same top-level cargo toml we talked about, but inside, in that crates directory, we've broken the application down by its function. This isn't just a messy list of files. This is your architecture, made visible. You can look at this folder structure and instantly understand how the system is organized. And each of these little boxes, these crates, has one job, and it does it well. The API crate, it just handles HTTP requests and routes. The services crate contains your core business rules. And here's the cool part. It has zero idea what HTTP even is. DB talks to the database, auth handles users, models holds all our shared data types, and worker is off doing background tasks. This is what we mean by separation of concerns, and it's the absolute key to building software that you can actually maintain and grow over time. So the magic question is, how do all these crates talk to each other? Well, in the API crates cargo toml, you just point to the other crates you need using a simple path dependency. That's it. This lets you link all your internal libraries together instantly. No need to publish them to a registry, no complicated local build scripts. It just works. It's so clean. Okay, let's follow a single request as it flies through our system. It comes in and hits the API crate. API immediately calls the auth crate to check the user's token. Once that's cleared, it passes control to the services crate to do the real work, the business logic. Services then uses the DB crate to get data from the database, and that data gets shaped into our shared models before being sent all the way back. It's like a perfectly choreographed relay race. Each crate does its one job and then passes it on. Clean handoffs every single time. So we've seen how powerful this is, but I can hear some of you thinking, wait a minute, isn't this just a monorepo like in JavaScript?
And you know what? You're right, it is. But the way Rust and Cargo handle this is fundamentally different, and that difference is everything. If you just look at the landscape, in Rust, it's simple. You use Cargo, and Cargo has Workspaces. It's a built-in, first-class feature. Then you look at, say, the TypeScript world. You have monorepos, for sure, but they're managed by a bunch of different competing tools, and it can all feel a little bolted on. And in Python, the patterns for this are still kind of emerging and less standardized.
But here it is, the absolute killer feature, the real difference maker: boundaries. In Rust, the separation between your crates is enforced by the compiler. The compiler is like a bouncer at the door of each crate. It says, nope, you can't touch that private stuff. In JavaScript, those boundaries are softer. It's more of a polite convention, one that's easily bypassed with a sneaky relative import. So Rust doesn't just suggest a clean architecture, it actively helps you enforce it.
So let's just recap what makes Cargo Workspaces feel so special. First, it's standardized. This is the official built-in way to do it. Second, it's performance-driven. It's not just an organizational tool. Its design actually makes your compiles faster. And third, it's unified. That one cargo.log file is your get-out-of-jail-free card for dependency hell. It's incredibly robust. All right, let's bring this all home. I want you to reframe how you think about this. A Cargo Workspace isn't just another feature on a list. It's an architectural superpower, handed to you right out of the box on day one. You know, in a lot of other ecosystems, you have one tool for your dependencies, another tool for your build system, and your architecture. Well, that's just a bunch of diagrams and good intentions. In Rust, Cargo rolls all three of those things into one single cohesive system. Your architectural choices have a direct impact on your builds and your dependencies, and the tool is designed from the ground up to support that. And this is probably the most important thing to take away from all this. Breaking your application into a workspace of smaller crates isn't some advanced, expert-level trick you pull out later. It's the normal, expected, idiomatic way you build a Rust project that's meant to grow. The tooling doesn't just allow it, it actively encourages it. It's part of Rust's core philosophy. So I'll just leave you with this question to think about for your own projects. Are you constantly fighting your tools to try and achieve a clean architecture? Or are your tools actively helping you build one? Because with Rust, the tool and the architecture are on the same team. And that changes everything. Thanks for joining me.